Here I have a potentiometer. Over here I have an LED. At the potentiometer I have positive, then this one, yellow wire is connected to analog 0, this one is connected to ground. Over here on the negative side the LED is connected to ground. On the positive side the LED is resistor and digital pin number 3. Here is my code, which I'm going to scroll up. So here I declared it an output. This one is for my serial monitor, which is over here. Now here's analog read. So analog read is pretty much reading the values on the potentiometer. And then the serial print line is printing it right here. So the values will show up on here. Right now it's at 0. Now I have an if-else statement. So right here it's saying that if the potentiometer's value is less than 400, then the LED will be off. If it's over 400, which is part of the else statement, then it will turn on. So right here, this is how it looks when it's at 0. So I'm going to show you as it increases on here. We're going to go all the way past 400, hopefully at 400. Okay, so you see how it increased to over 400. And now my LED is on. Alright, here I have a Vex line tracker. Right over here on the white is connected to analog 0. So right there is analog 0. Red is connected to 5 volts on the positive side, and then this is the negative side connected to ground. Here we have black and white tape, so that's what this line tracker is going to read. And to do that, here's my code. So we have to use serial monitor, and it'll tell us whether or not it's reading a black or white tape. The way to do that is by first off saying the serial begin. So pretty much that's what's our setup for the serial monitor. And then we have over here it reads the line tracker off of analog 0. So that's how it's going to read the value of it and determine whether or not it's going to be a white or black line. Next we have the if-else statement. So I said if the line tracker's value is over 900, it's going to say black line detected or black tape. And then if it's below 900, it's going to say white line. So I'm going to show you that now. Okay, so first I'm going to take my line tracker, I'm going to put it over the black. Black line detected, it's going to say, see? Now I'm going to put it over the white line, and it reads white line detected. Here I have 2 LEDs and 2 push buttons. On the positive side are the wires. Yellow is hooked up to digital pin number 10, red is hooked up to number 9. On the negative side of the LEDs is a resistor. Over here we have 2 push buttons, set up and pull up. The green is the negative, and then on the positive side you see a resistor, which is hooked up to 5 volts, and then we see these wires right here. And this one, yellow, is hooked up to number 3, and red is number 2. And then we have the code right here. So inputs and outputs, buttons are inputs, and LEDs are outputs. Over here we have our loop. So inside a loop we have a digital read, meaning that it's reading the button. So if the button's on or off, that's what it's reading. And over here is the if-else statement. So I have 2 of them, one for each LED. So this if statement for the red LED is actually saying that if the red button is off and the yellow button is off, then it is, well, seeing as how this is a pull-up, it would do the opposite of what we say. So we're saying on. In reality, it's not on till you push both buttons. And then course, else is what happens if that statement is false. And then this one is saying that when the yellow button is off, it is not equal to when the red button is off. So pretty much what this is going to do is if I press only one button, it's going to turn on, but if I press both buttons, it's going to turn off. So I'm going to show that to you. So like I said, if I press one button, I'm just going to demonstrate, the yellow LED turns on, one button turns on, but when I press both, the red one turns on. Here I have 3 LEDs and 3 push buttons. Right here, you'll see on the positive side are wires hooked up to digital pins. Blue is hooked up to digital pin number 11, yellow is 10, and red is 9. On the negative side, you'll see resistors hooking up to ground. For these push buttons, you'll see that on this side is negative, which is ground, and then on this side you'll see the resistor hooked up to positive, which makes it an input pull up. If it was hooked up to the negative, then it'd be pull down. And here the wires are hooked up to digital pins number 4, 3, and 2. Now I'm going to explain a little bit about the pull-ups. So here's the code, and with this code I stated that 2 through 4 are inputs, and then 9 through 11 are outputs. Buttons are inputs, and then the LEDs are outputs. Here are the names of the LEDs. I mean, not the LEDs. Here's the names of the buttons, sorry. Digital read pretty much means that it's reading if the buttons are on or off, or being pushed or not, should I say. Right here, okay, so here's where I explain the pull-ups. The thing with pull-ups is it gives you the opposite command of what you're saying. So like for instance, on a normal basis, if I said that red button equals 1 or on, then usually this would be high, meaning on. But because a pull-up pretty much inverts it, it's going to end up the opposite of what you actually expect it to. So first I'm going to show you the way I have it now. So here's how it is. So the way I set it up, if I push the red button, the red LED comes on. If I push the yellow button, the yellow LED comes on, and then blue, the blue one comes on. And then I'm going to show you the invert. So if I say that, if I leave it the same, the only difference is if I put what it should be if it was normal. If it was normal, then I'm going to show you what the invert does to it. So let me show you. So because of the pull-up, this is what happens when you state what it should be. It pretty much gives you the opposite. So this is supposed to be off. So if on a normal basis this would be off, but because this is a pull-up, it's actually giving you the opposite of what you want. So yeah. Alright, so here I have an RGB LED. Right here you'll see some resistors all connecting to color-coded wires by which color represents. So this wire is connected to digital pin number 11. This one's hooked up to number 10, and red's hooked up to number 9. Right here we have ground. Okay, and on this side we see some push buttons. Yellow is hooked up to positive. Resistors are hooked up to the ground, and in front of the resistors you'll see the wires that are hooked up to the pins. So blue is digital pin number 6, green is number 5, and red is number 3. And I'm going to explain to you the fact that this right here, because the way these buttons are on the circuit, it's circuited as an input pull down. Reason why is because the resistors are hooked up to the negative. If it was hooked up to the positive, it would be a pull up. Okay, and now I'm going to show you my code. So here's my code. The buttons are inputs and the LED is the output. So here we have a digital read, meaning that it's reading if the buttons are on or off, so that's what it's going to read. And then here we have the if-else statement. So if red button is equal to 1 or on, then this LED, which is a red LED, will be on as well. And then the else statement is if the button's not pushed, then the LED will be off. So that's the same for each button. Now I'm going to show you how it works. So it's saying that if the red button is equal to 1, so I'm going to show you when it equals to 1. So I'm going to push down, so that's 1, and then when I let go is 0, so on off. So when I push down, the red light will come on. If I push down on the green button, then the green light will come on. If I push down on the blue button, the blue light will come on. If I push down on the red and green button, yellow. If I push down on the red and blue, I get purple, and then blue and green, I get cyan. Here I have an LED. Over here I have an LDR. LDR stands for light dependent resistor. You'll see what it does. Over here we have, on the negative side of the LED is a resistor. On the positive is connected to digital pin number 9. For the LDR, on this side, I'm going to call it positive because it's hooked up to the positive. So the yellow wire is hooked up to positive. And then we have a resistor hooking up to ground, and then the white wire connects to analog 0. And so how this is going to work is with my code. So I set up the LED as our output. As we go down, we see that LDR is equal to analog read, which means that it's going to read the LDR, so the value, it's going to read it. And then we have the if-else statement. So here's the if statement. If the LDR value is greater than 500, then the LED will be on. If it is less than 500, then it'll be off. And the way that it works is, the way it's over 500 is when light shines on it. So I'm going to show you right now. See how it's on, and I have light shining on it. And then if I cover it, then it turns off.